Today we're going to talk quickly about Go contexts. Contexts in Go are deceptively simple but powerful idea, concept and structure in Go, which can give you a lot of power if used correctly. So the first thing, what is a context? A context is a type declared by the context package, which is a built-in Go package, and the context has just a few values. I'm not sure if this will give them to me. Okay, yeah, so a context that we're actually using here is an interface with a few methods. So it has a deadline, which we'll look at shortly, this done channel, the idea of an error on a context, and also values, which we'll touch upon. But like I say, they can be very powerful, but only if used correctly. Now, the first most important thing about contexts in Go is if you're going to use them, you should use them everywhere, which means that every time you declare a new function, the very first argument, and this is a Go best practice, the first argument is always a context passed as a value like this. And CTX is the basically accepted way of describing a context value. So you'll see CTX everywhere. This is how you should name your context as a value as you're passing it around. It's just accepted as the best practice now. And the second kind of general best practice for context, before we get too deep into use cases, is that you should never pass a context inside of a struct. So you might be tempted, if your function signature is getting rather long, you might be tempted to declare some type which will take all your args and, for example, pass in the context here. But you should never do this, because your context should have a scope, and we'll see exactly what I mean by scope shortly, but your context should have a scope. And as soon as you start to pass it around in a struct, you confuse what that scope is, so you confuse where the context is meant for. Whereas when you pass it in as a parameter, as the argument to a function like this, it's quite clear that this context is for the scope of this function or method. So don't pass structs around. Don't pass context in structs. Those are the two very general best practices before we touch on some use cases for structs. Now, as we were looking at the context type signature a moment ago, one of the things we saw about a context is that it has this value field. So what you can do on a context is store values. So imagine you're working on a web server, for example, which is going to serve HTTP requests. You'll get a new context for each request that you serve. So what you can do on this context is store some data about the context of the request. For example, imagine you had a user ID for your request. What you can do is wrap your context in a new context. Wrap your existing context in a new context, which can have a value, a key and a value. So you can store it essentially in a map. Now I'm not going to go too deeply into this, because in my opinion, you should never actually do this. For one, context with value are untyped. You may have seen in the signature here, if I show that again, that the key and the value are both empty interfaces. They're untyped. So in order to then read these later, which you can do with context.value passing the key, as you can see here, you're going to have to pass an interface type and get back the interface type. So these untyped values are very much against the typed nature of Go, right? So for one thing, you're introducing complexity and a little bit of risk, as you need to know both what the the type of the key is and the type of the value is in order to be able to interact with them. But secondly, there's really no good reason to pass values around on the context, because instead you can just pass them, for example, as arguments here. Instead of setting the user ID on the context, you can pass your user ID here, for example. Now, there will be times, I know I've had them, where you're tempted to store values on the context for convenience, because you don't want to have to pass values all the way through a call chain, for example, and you can just stick them on the context and read them later. Resist that urge would be my opinion. Yes, it can be convenient to do that, but it introduces some complexity, it introduces some risk, as you've got to coerce interface types, which can lead to panics, which then you need to handle. Don't do it. It's not the go way to do this kind of thing, to pass around untyped values on, especially on context types like this. It has been suggested that adding this value map onto the context was a mistake, and I probably agree with that. So I wanted to let you know about this value kind of map on the context, but my advice would be to never use it. But what we've touched upon here, the way we created this context by wrapping it, is something I want to touch on next, which is the idea that what you start at the root of your function, you start with a root context, and you might define the root context like this. If you're using if you're running a web server, you might get a context out of the handler library that you're using. But let's imagine you start with a context like this. You've then got the idea of child contexts. So let's, for example, I'm going to do two things. So let's say do work A, because I need to, let's say, for example, I want to call database. I want to pass in here a context, and then let's say I also want to read a file. Now, for reasons that I'll explain later, what you might want to do is pass a child context into each of these. So rather than passing this context, you might want to create a context, which this is the parent, and create two children. So for example, let's say a DB context, and we can create a new context by using the context package, and you can see it gives all of these kinds of context wrapper methods here. For example, I could use context with value if I want to set a context on there. I could do a deadline with cancel. And so for example, I might want to be able to cancel this database call, which I'll explain in a moment. So I can get a database context like this, and then pass in the DB context. And let's say down here, I want to, let me see. Let's say this is called file context, for want of a better word. We could, for example, add with timeout here. Again, timeouts we'll get to shortly. But I pass in the parent context in here, and I get out this child context, which I can then pass in like that. Which raises the question, why would I want to use child contexts? And the reason is that we may want to use some other features of the context implementation specific to an area of the code. For example, context has this idea of cancellation. So if you look up here at the signature, you can see that the with cancel returns the new context, which is a child context, along with a cancel function. So actually it returns a cancel like this. So now I can pass in the database context, and if I at any point want to cancel this database call, I can call cancel. And if the database call is listening to the context done channel, which I'll show you shortly, then we'll be able to see that actually calling the cancel here will cancel the database call. So let me show you how that works, and then we'll look into a couple of different ways that we can use this. So let's add an artificial sleep here, which will be time.second. And then, so we'll call cancel after 1 second. Now, if we implement func call db, which will take a context, and let's say that this, obviously normally this would just call the database, but let's say, for example, that this sleeps for 1 second before returning. What we then need to do is listen on the context itself. So the way that we do this when we are listening to a context is using a select. So the context has a method done, which will return a channel. And this channel, as you can see in the documentation here, this channel will be pushed to when the context is cancelled or times out. So obviously we're looking at a cancelled situation for now, but we can talk about the other situation of timing out automatically in a moment. So if we get the context done, we know that we're cancelled here. Otherwise, let's actually define a new timer, which will mock our database call, and let's say we'll wait for 2 seconds, yeah, and the timer returns a channel called C, and then we'll print read from the database. So in reality, what we'll be doing here is, on this case, we'd be looking for the database call to return, rather than just mocking with a timer. But for now, let's, instead of adding a database call, we will mock it with this timer, and hopefully your database doesn't take 2 seconds to return either. But this is purely for demo. So to clarify what we're going to do for this experiment here is we're going to create a context which we can cancel. We're going to pass it into this method down here. We're going to sleep for a second, and then and this needs to be concurrent so that we witness this. So we're going to call this in a go routine. We're going to sleep, and then we're going to cancel. Down here, we're going to see what happens. We're going to listen for the done channel, and we're also going to wait for our database call to return, and the select will return on whichever happens first. So if the cancellation happens before our database return, we'll see that we got a cancelled message. Otherwise, we'll get a read from the database message. So let's save that and run this and see what we get. Clear away these fish errors. And I have, yes. So I actually need to, let me delete all of this. And actually I'll just make this the main function, and we don't need this. Okay, save that and rerun. Yeah, I also need to initialize the context variable. And we got nothing, which is not great. I wonder why we got no, because cancel would then end, let me, there we go. So what you can see, and by the way, I added this extra sleep because after the cancel, the process was finishing before we could print. So adding this delay just allowed the go routine to complete. But you see we got the cancelled message here because we received context.done before the new timer, which is our mock database call, could complete. So just to demonstrate the other case here, let's imagine that this, rather than taking 2 seconds, takes half a second. So what we should see now, if we run this, is that the database call completes in 500 milliseconds. So it completes before we can call cancel. So we should see read from the DB rather than cancel this time. There you go. So that is the case where your database, which returns before you cancel the context, which you would hope is always, in which case you would get your read from the database message instead, or hopefully just the value of the database returned. Okay, so that's a kind of contrived example where we're doing this cancellation ourselves, but the context allows you to be a little bit smarter than this. So instead of setting a context with cancel, let's define one with timeout. And if I show you the signature of a timeout, it takes the parent context, which is going to wrap just like before, and a timeout duration. So yeah, this time we can pass in a duration. So just like before, we were passing in this second. It also will return a cancellation function, which you should always defer to cancel anyway. So whenever you get a cancel, you should always defer a cancellation immediately, because that way you'll ensure that the context was cancelled, even if it hasn't been yet. So we're going to do the same as we did before. So we're going to pass in this context to this go routine. And down here, what we're going to see, same as before, exactly the same. We're going to take this context, we're going to listen to it, we're going to read from our mock database. I'll put this back to 2 seconds, just so we can see the timeout. And I don't need, and then what we'll do is we'll just add a delay here of 5 seconds, just to make sure that the process again doesn't exit before we've done all the work. Remember, if you're running a web server, you've got a port opening you're listening, so the process won't exit. But in this case, this is just to mimic that kind of ongoing process. Okay. So down here, let's run this again. If we wait a second, again you can see it's cancelled. But this time we haven't run the defer yet. We haven't cancelled manually. This timeout, after a second, has called the cancellation function for us. So by saying for a set time second here, we've timed out after 1 second. But if we make that 3 seconds, so we only want to time out after 3 seconds, we give our database 3 seconds to return. Then down here, because we have this database call returning after 2, we get read from the database instead. So this channel returned first. So that's a basic way that we can use a context for timeout for concurrent code. But I want to show you one kind of slightly more complex example of this that demonstrates the nested nature of contexts, which is that we can, if we go back to the previous example that we were using, where we were also reading a file. So let's say read file, and this will take a file context. Now, because the contexts are, let me copy this, because the contexts are independent, because we're creating a context for each here, file context, we can set different timeouts. So for example, I might want the file read to finish inside 2 seconds. So if I also copy all of this and paste it up here, and change the messages just for clarity, cancel the file, and I'll say read file. So now what's happening is we have 2 independent, and let me call this cancel 2. So we have 2 independent contexts, each from the same parent, but will run independently so they can have different timeouts. So for example, if I run this again, I misnamed this. Let me just change this, read file. So in this case, both of them pass because they have the same timer. But let's say, for example, that the file is a really big file and it's going to take 5 seconds. We can change the mock read. So you can see that we cancelled the file. We cancelled the file because its timeout was 5. But let's demonstrate that these timeouts are different. So for example, if we make this timeout 4 and this one 2, you should now see that this one will fail because it is longer than the specific timeout for the file context. Obviously it's shorter than the database context, but they're different. So not to belabor this point, but the context children give you the ability to use the same parent with different timeouts for different use cases. But we can also set a global timeout value. So let's say this was the request, and we might give ourselves, maybe 1 second to read the database and 1 second to remove the file. But we can actually set the global context, say that the root parent context, to have its own timeout, which will cancel both. So let's pass in context time dot. Let's give it a ½ a second timeout. So actually that wouldn't make sense normally if these things were taken a half, but let's just say for now that it's half for demonstration purposes. Sorry, and this also will take a cancel, which I will defer. So now what we should see is that both of them, I need to, you can see that both were cancelled, even though, and let's make these longer just to demonstrate. So what we should see is, even though neither are going to exceed their individual contexts, they will exceed the global context, the root context. So an example of this is, imagine you've got lots of work being done. For example, let's imagine that you had, you were going to read the database, and then you were going to read a file, and then you do lots of other things, which you probably do on the request path of a complex system, right? You probably want to set a global timeout for the entire request, and then individual timeouts for the pieces. Well, this is how you can do that. And you can infinitely nest context, so children can have children, and when you cancel the child, you cancel all of its children, but you never cancel the parent. So it cascades downwards but not upwards, which is a really nice feature of context. So it means if you're doing, for example, you're doing lots of database requests, you could have a root parent for that. They're all happening. You can cancel all of those without affecting the parent, so without affecting other things that you're doing too. So the nesting of contexts, which I probably haven't explained very well there, is a really nice feature and something I'd encourage you to use very, very heavily. So we've looked at how we can use contexts within a process to establish timeouts, to cascade those timeouts through children, and to manage the request lifecycle through those timeouts and cancel methods. But one incredibly both powerful and neat thing about kind of Go, at least in the versions that we have today, is that inside the native Go request object, it supports passing context over HTTP. So I wanted to do a very quick demonstration of that. For example, what I've got here, let me just explain it quickly. So I've established this context here with a timeout of 4 seconds. Of course, we're remembering to defer it. We're going to set a value on there just for kind of demo purposes. Then here, we're using the new request with context method, again native to Go, which creates a new HTTP context object, new HTTP request, including a context. We're not going to pass a body, it's just a Go request to a local server, and then we're going to make that request and print any errors that we get. And then over here, I've got a very simple server, and you should recognize this pattern from what we saw before. So we're going to listen. So first of all, we're going to print that we've received the request just for debug purposes. And then on the HTTP request, again, the native request type from the HTTP Go library, on the request, we have this context method. And what it returns is a context. In fact, the very context we passed onto the request in the client. So if you have a Go client and a Go server, this means that you can natively pass context objects between the client and the server. So what we're doing, as you'll remember, is listening on the context channel, and also, again, we've got this artificial timer here, which we're listening on, which will print time, or let's print something more useful than that. Let's print complete, and let's print up here timeout. And then we're gonna, if we succeed in reaching this timer, we will print complete and then write hello just for ease back on the HTTP response. So again, we're testing whether the timeout is hit first or this timer. Here we've got it set to 3 seconds. So this is not that easy to read on the split screen. We've got it set to 3 seconds, and on the client over here, we're going to set our timeout here on the context to 4 seconds. So the first thing, if I run this server, the first thing we expect, because the timeout is high, 4 seconds, and our server should respond after 3 seconds, we would expect when we run the client that we see success on the handler. It should say complete, there we go, and no errors, which is absolutely fine. But if we turn down this timeout value for the client context to 1 second and make a new request, what you now see on the right hand side is a timeout, and we also get back the error context deadline exceeded. And we get back that error, rather interestingly, as a native Go error here, rather than having to pass the HTTP body. So I think this is pretty cool. We're using only native Go libraries, so we're doing nothing custom. We don't have to marshal the context ourselves. We're just reading the context, setting the context on the request, reading it off the request on the server side, listening for the timeout, and when it times out, again, a timeout we set on the client, when it times out, the server is alerted on the native channel, at which point it's going to print this error, and not only print this error, but also take care of passing back this error context deadline exceeded for us. So the server has to do no work to let the client know that the timeout you specified has been exceeded. And I think that is pretty impressive. So with that, I think I'll leave it there. But I think contexts are incredibly powerful despite their simplicity. The idea of being able to kind of nest children so that you can control the entire request path in a granular way by setting timeouts for groups of things and individual work, having these timeouts built in natively, and then being able to pass them with no effort natively across the network, I think is incredible. So I encourage you to make incredible abundant use of the context type in Go, and I hope it can be as useful to you as certainly I have found it. Okay, thank you for watching.